Hey, Walter Sorrells back with another Knife Makers Friday 5. Today, a big lie I told and more about how to drill great holes. So drilling is a really important part, I guess you'd say kind of an underrepresented part of knife making. A couple weeks ago I did a video about drilling and it actually ran so long that I kind of laid one chunk of it aside, and I'm circling back to that today and I'm going to play the rest of that and that's going to be mainly what we're doing in this video. Basically what I'll be talking about is how to accurately drill holes without actually using fancy machines like jig borers or CNC machines. So more on that in a minute, but first a few channel updates. So first, last week I forged this fairly cool knife. If you haven't seen the video about that, check that out. I'll provide a link to that in cards and description. Also, the brick, the Sorrells brick, is back in stock. If you haven't seen information about how that worked, I got a whole video about that. And upcoming, I want to do a video where I actually show how you use this grinding jig. I think it's pretty cool. It has some big advantages and a few limitations, and so I want to kind of go over all of that in a video that'll come in a couple of weeks. If you want to buy one, they're at sorrellstool.com. You can also get them from Pops. A few other upcoming things. I've got a review of the Broadbeck grinder that I showed probably about 2 months ago. I showed a video about how to make a grinder from a kit. This is a 2x72 grinder made by Broadbeck. I've had a chance to use it a bunch, so I'll be doing a review about that in a couple of weeks. Okay, so I promised up top that I told a big lie. I don't know if it was really a lie, but it turned out not to be right. So the deal is, about 6 months ago, I would say, I did a review of a laser that I use to do logos and stuff like that. It was one of a whole bunch of different reviews of lasers that I've done. There doesn't seem to be tons and tons of interest from you guys about my use of lasers in the knife making shop. So I promised I wasn't going to do any more laser videos. Well, I got the opportunity to get my hands on a really cool laser, an X-Tool F2 Ultra, if you guys are into lasers. And so I'm going to be getting hold of that, and I am going to be doing some videos about that. I just couldn't help myself. I'm kind of an evangelist for lasers. I think they have a great place in the knife making shop, and like I said, this is a very capable laser, I hope. We'll see once I get it, but assuming that it is, I'm going to end up doing a review and a couple projects with it. All right, let us now turn to the main feature of the day, which is more about drilling. So like I said, I did a thing 2 weeks ago about drilling, all kinds of little tips and tricks. What I'm going to be doing today is just walking you through a very structured approach to drilling accurate holes. All right, so cut to the video that I shot 2 weeks ago, and we'll finish that off. There are a lot of different reasons you might make a hole, and sometimes what you're looking for is just something to run a bolt through. You don't need a lot of tight tolerances. You don't need it to be super carefully located. You don't really care if it's, you know, a little bit off parallel or off perpendicular, whatever. But sometimes, and this is especially true, say, in folders, but sometimes in any kind of knife making, you want a pretty precise hole. So what I'm going to walk you through here is the sort of most old school approach to locating holes in a precise way. The reason I say old school is because most hole drilling today is done in industry on CNC machines like the one I've got back there. You program everything in, and there's a set of routines that you go through to reach whatever level of perpendicularity and finish and tolerances and all that sort of thing that's completely different from the way that you do it if you're trying to do it by hand. And this is how the old school machinists did. So basically, here are some of the issues that you're trying to solve when you're drilling a hole, if you're trying to do it reasonably precisely. The first thing is you actually want the hole to be where you want the hole. It's very typical when you're drilling a hole in a tang to drill it slightly off center or something, and then, you know, it's not necessarily going to look horrible, but just to your eye as you look at that handle, if the pins are in wonky places or they're kind of uneven, one's higher and one's lower or something, it's just not going to look very good. And so you may want that hole to be very precisely located, centered in the space of the handle. Maybe you're drilling holes for the pivot on a folder. You want those to be located in a very precise way, and you want them to be very perpendicular. If a hole is not square, then when that blade pivots, it's going to pivot off axis, and it's going to, you know, want to whack into the scales when it folds up, or it's going to look cockeyed. It's just unprofessional to drill your holes cockeyed. And so that's another reason for wanting to drill good holes. So what I'm going to do here is talk about all these different, or just this whole sequence of things that you can do to locate the hole and then drill it properly. So the first thing you want to do is to locate the hole. I'm looking for, here we go. So there are a million different ways of using, in machinist world to locate holes using old-fashioned methods, basically height gauges, little scribes, calipers. I'm not going to go through the whole process, but you know, a standard thing is to put layout fluid on things, measure very precisely where you want that hole, and then scribe little lines, and wherever those lines intersect or wherever you lay them out, that's the point that you want to drill your hole. So, okay, that's the first thing in locating, is to just use some kind of measuring tool to measure precisely where you want that hole, and then use layout fluid or just scribing aggressively into the metal a nice precise location for that hole. Okay, so now let's just say you got that thing located, you go slap it on the drill press, you say, it looks about right. It didn't matter that you went to all this trouble locating the thing, your drill bit is not going to hit that hole correctly. So if you're not super concerned, crazy concerned about the precision of that hole, you can just look at that thing and then very carefully, you know, maybe you use a little magnifying glass or reading glasses or whatever, or if you have good eyes, you can just do it by eye. You line up that center punch with the hole and you whack the center punch. So the old-fashioned center punch here has a point that's not super precise, because what you're trying to do is do a big crater there that your drill bit will insert into. So if you want it to be super precise, what you want to do first is use a prick punch, which is a punch that has a very sharp point to it. And so you're going to very precisely locate that, you know, maybe under magnification. This would be the way the old-fashioned guys would do this. And you put it right on that line that you've scribed, or the intersection of those two lines that you've scribed, and you'll hit the prick punch and get this tiny little hole, and then using your heavier center punch, you'll insert it into that thing, and you can do this by feel. You want to do it by eye and by feel, and make sure that you're inside the hole, the little crater that you've done with the prick punch, and then you'll whack that, and that'll create another hole. And of course, there's spring-loaded center punches that you can use. There are a lot of different ways you can do this, but that'll give you a deep crater. And the point of that crater is now you put the center of your drill into that little crater and the drill bit won't walk. See, what tends to happen if you just take a drill bit and start drilling is that the drill bit has a little flex in it. And so it'll start to what they call walk. It'll skate on the top of the steel a little bit and it'll cant over, and then it'll bite in and start drilling. Now, if you're just looking at it with your eyes, you might not see that it's walked. And so you start drilling, and what happens is instead of going at a 90-degree angle, maybe you go at 91 or maybe you go at 92. The hole's not exactly where you wanted it, and it's not square. So, not square in this sense, but square to your table. And so, if you don't have a little crater there, then you're not going to be able to get that drill bit in there and get an accurate hole. Now, there's one other thing that you can do in this sequence if you want to, and that's to use a spot drill. So what a spot drill is a shorter drill. It doesn't have flutes that go all the way up. It's basically just intended to make a little dimple there for your next drill bit to go into. And so you use a spot drill, which is very rigid and short, to just make a little dimple there. So if you're going through this whole sequence, you're going to locate it, you're going to prick punch it, you're going to center punch it, and then you're going to spot drill it. And so the spot drill is just going to be a tiny little dimple, a little bigger than the one that you made with the center punch, but not, but you're not actually really drilling a hole. So it just gives a more robust point for that final drill to go into. Now, when I say final drill, here's something else you can do if you're trying to do this super accurately. And that is, let's say you're drilling a 3/8 inch hole. You can drill your first hole with an 1/8 inch or a 1/4 inch drill, and then you're using the 3/8 inch drill to drill the final hole. It's not so much an accuracy issue in this case. What you're trying to do is save the drill. So the point where drills wear the most is the actual point. So there's a lot of pressure that goes on there, creates a lot of heat, a lot of wear, and so the more that you can spare that little point as you're drilling, the longer your drill is going to last. So there's a case to be made for, spot drilling it and then drilling the small hole and then drilling a bigger hole. And if you're drilling huge holes, you might even do 2 or 3, in a row. You might go 1/8, 1/4, 3/8 to half or something like that. Kind of gilding the lily, but you can do that. Now, can we make this even more complicated? Yes, we can. What if you want a really, really precise hole? If you're doing pivots on a knife, for instance, if you take a 1/4 inch drill bit, so let's say that's a really well-made drill bit, it's exactly 0.2500 in diameter, and you drill a hole with it, are you going to get a 0.2500 hole? Probably not. The reason for that is that as the drill wears, and there are just a lot of factors that play into it, but the drill is going to move around a little bit. And so it might not drill perfectly concentrically. It might drill out of round a little bit, so you're getting something that's a little elliptical or that has almost like little flutes scored into it, or it's just slightly oversized. All these things can go wrong when you're drilling with just a plain old-fashioned drill bit. Terminology footnote here for you nerds. Machinists don't call them drill bits, they call them drills. So if you're around a machinist and you call them a drill bit, especially an old school crusty guy, they may complain about this and say, no, it's not a drill bit, it's a drill. So when you hear me calling something a drill, I'm not talking about this, I'm talking about a drill bit. Anyway, so final point here. If you want something to be super accurate in its diameter and its concentricity, the tool you want to use is a reamer, which is essentially a drill bit, but it's a specialized tool for making very accurate holes. So when you are reaming holes, what you want to do is you drill slightly undersized, and it depends on how big the final size is as to how much undersized, but it's usually a few thousandths of an inch. It's not, it's not a big old honking amount. So you're drilling very close to the final diameter, but not quite there. Then you take a reamer, which typically, though not always, has straight flutes and is ground to very, very precise dimensions. And you run that reamer down there through there and get yourself to your final dimensions. And so for folder making, a reamer is really, pretty much your standard final cut, because you're looking for a really, really carefully dimensioned hole so that there's no slop in that pivot. So just to recap this whole process, and again, I'm telling you the most complicated process you could possibly do, but it's good to know the whole thing so that if you want to harvest little pieces out of this to drill a little more accurately, then you can. I probably have never done this entire process from soup to nuts, but if you're trying to do super, super precision hole the old-fashioned way, this is the way to do it. So you locate, and then you prick punch. Now, by the way, there's a thing called an optical punch, which is a cool little tool that you can use in this situation. What you do there is you have a little base with a clear glass or lucite core in the center that has a little dot in it, and you look through there, you locate the lines that you've scribed, and then you pull that, and you're able to do this very precisely by looking straight down and seeing where the little locator, it's like the reticle of a rifle. You put that reticle on the spot that you're trying to drill, you pull out that little piece of lucite or glass, and then you drop a little punch in there, whack that punch, and you got a hole that's or a punch that's very, very precisely located. So you can't even insert that step in there. But anyway, prick punch, center punch, then spot drilling, if you want to use that step, then a pre-drill or pilot hole, and then your final dimension, and then finally reaming. Again, 99 times out of 100, you don't have to go through all those steps, but it's all available there to you. And you can do all of that on just a bone simple Harbor Freight drill press and get something that's basically as accurate as, a $100,000 CNC machine. All right, so we'll wrap it up there. Drilling is just a super important part of making knives, and so I think this is pretty valuable stuff. One last thing, don't forget, I do have lots of bricks in stock here at Sorrells Tools, so if that's something you've had your eye on, check that out, and I think it's a really pretty cool tool. So, all right, thanks for watching, guys, and keep on making those knives. Thanks for watching, guys. If you like what we're doing here, please subscribe and make sure that you click on that bell so you get notified of all the latest videos. Want to buy a knife from me? Check out my modern blades at tacticsarmory.com. Digging the channel? You can support our video making efforts on Patreon. I've been banging away on these videos for like 10 years, so I hope you'll show some love for all that hard work. Link in the cards and descriptions. Finally, if you're interested in making Japanese swords, check out my full line of Japanese sword videos where I show how to forge Japanese swords as well as how to polish them and how to make fittings, handles, and scabbards. WalterSorrellsBlades.com.